Hello everyone, and welcome to this presentation, which is all to do with quadratic functions and their graphs. So we're going to start with a little bit of recap from GCSE, and then we'll once again step it up to A-level once we've mastered those skills. So first of all, on a whiteboard or on a piece of paper, can you solve the following equations? So first of all, x squared equals 16. And if we take the square root of both sides, we will end up with both values of 4 and minus 4. Please don't forget that we have two values of x that work for this equation. Number 2. So in this question, we've got an extra step. So first of all, I would take 3 from both sides to give x squared equals 25. And then I would square root both sides to give me x equals plus or minus 5. Number 3. In this example, the first thing I'd do is add 5 to both sides to give 2x squared equals 18. Then I'd divide by 2 to give x squared equals 9. And then I'd take the square root to give me plus or minus 3. Number 4. Same as with number 1, all I'm going to do here is take the square root of both sides, and I end up with values of root 3 and minus root 3. It's perfectly okay to have surd answers. Number 5. Good, a little rearrangement of this equation, and we end up with x squared equals 4, which means that x will equal plus or minus 2. And finally, number 6. Very tempting to multiply out the brackets in this question, but there really is no need to do that. The most efficient way is to take the square root of both sides first, which would lead us with x plus 2 equals plus or minus 2, and then we would take away 2 from both of those answers to leave us with x is 0 or minus 4. Okay, great. So your turn to practice those skills. So you can either do these in your notebook if you want a few examples of what we've just learned, or again, you can do on a whiteboard or on a bit of paper. Spend a few minutes working answers out to these questions. You can pause the PowerPoint if you need to, and I'll give you some answers in just a minute. Okay, so with A, if you take square roots, you get 6 or minus 6. B, we would add 3 first to give 100, and then by taking the square root, we get 10 or minus 10. C, we would add 4 to give 20, divide by 2 to give 10, and then take the square root to give us root 10 or minus root 10. D, a little bit of rearranging to do first. So if we gather together the like terms, we end up with 2x squared equals 18. Then we would divide by 2, which would give us x squared is 9, and then take the square root to leave us with 3 or minus 3. E, again, rearranging would give us 2x squared equals 10. If we divide by 2, we then have x squared equals 5, and then by taking the square root of both sides, we end up with root 5 or minus root 5. F, again, it's tempting to multiply out the brackets, but there's no need. So first of all, square root both sides, giving us x minus 1 equals 5 or minus 5, and then add 1 to each of those two answers to give us x is 6 or x is minus 4. G, again, square root both sides first is the best way of going about this. So 2x minus 6 would be 2 or minus 2. And then in the same way, we'd add 6 to both of those answers, then divide by 2, and we end up with the two answers of 4 or 2. And then finally, same again, add 7 to both sides to give you x plus 3 all squared equals 12. Then take the square root, which will be root 12 or minus root 12, and then take away 3. And as you can see here, that's how we would present our answers. Okay, so sometimes we're presented with an equation to solve that looks like this. And again, there really is no need to multiply out those brackets first to find the values of x, because this is in factorized form. And if a quadratic is in factorized form and it's equal to 0, it's very simple to find the solutions, because you're making either one or the other of the two brackets equal to 0. So for this question, x would have to be 1 or -3. In this one, the values of x that make those brackets equal to 0 are -2 and 4. So if you replace x with either of those two values, you will find that the answer is 0. Number 3, same again. The values of x that make those brackets equal to 0 are -6 and -2. Last but no means least, in this one, we have x on its own, but that's almost as if you have a bracket with x -0 inside it. So the two values of x that make these brackets equal to 0 are 0 and 5. Okay, good. So the purpose of this slide is to show you that actually these two equations are exactly the same as each other. The first equation is in what we call completed square form, and the right-hand side is the factorized version that we saw on the previous slide. So if I was going to solve the completed square version on the left-hand side, the first thing I would do is I would add 4 to both sides, and then I would take the square root of both sides to give me two values, 2 and -2, and then if I take 3 away from both of those answers to finish off, I would get values of x of -1 and -5. On the right hand side, a bit like on the previous slide, either x plus 1 would have to equal 0 or x plus 5 would have to equal 0, leading to solutions of -1 and -5. You'll notice that the values of x for both of these equations are exactly the same. So here are those two equations again. They're exactly the same as they were on the previous slide, and the way that we can also prove that they're the same is we can expand the brackets and see what we get. So in the first one, if I was to expand x plus 3 all squared, I would end up with x squared plus 6x plus 9, take away 4 equals 0, and if I then simplify by collecting like terms, I end up with this equation here. On the right hand side with the factorized version, if I multiply out using whatever method you know best, we end up with x squared plus x plus 5x plus 5 equals 0, and if I simplify that by collecting the like terms, I get exactly the same. So another proof that these two equations are exactly the same as each other. Okay, good. So a little exercise for yourselves. We've got 5 equations on the left-hand side that are in factorized form. We've got 5 equations down the right-hand side that are in completed square form. What I'd like you to do is to match them together to find which ones are the same and find those values of x that do make the equations equal to 0. I'll give you a few minutes. You can pause the PowerPoint and then I'll give you some answers. Okay, good. So it turns out that first of all, these two equations are the same and both have solutions -4 and -2. Secondly, these two equations are the same and they have solutions of -3 and 5. These two equations are the same and have solutions 1 and 3. These two equations are the same and have solutions 2 and -6. And then that leaves us with these two equations, which are the same and have solutions 0 and 6. Okay, so this slide is all about notation and definition, so please make sure that you write these notes down in your notebook. So first of all, definition of a quadratic equation is a polynomial equation where the highest order of x is x squared. So the example shown there is a typical quadratic equation. If that quadratic is equal to 0, then there will always be two solutions, and those solutions are called the roots of the equation. Now you might have two distinct real roots. In other words, you've got two different values. You might have two repeated roots, which is where you've got two values that are the same as each other, or you might have no real roots, in which case you will find that you can't solve the equation given. A quadratic equation can be written in different forms, and each of these forms help you find different information about the equation. So really helpful to know all of them. The first is expanded form, which is, as you can see there, the original equation. There's factorized form, which is typically looking like that. And then finally, as we said earlier, completed square form would generally look like this. And each of those three versions tell us something different about the equation and also the graph as well of that equation. So on this slide we're going to look at factorising quadratics, and we're going to assume that the quadratic that we look at here can be factorised. There are other methods that we'll look at later on for when things get a bit more complicated. So presuming that 2x squared plus 11x plus 5 can be factorised, I'm going to set up the factorisation with two brackets. And we've got to make sure that the first two terms in each of these brackets are going to multiply together to give the 2x squared. So I'm going to choose 2x and x to start with. And I also know that the two end values in each of the two brackets need to multiply together to give 5. So I'm going to choose 1 and 5. And I've got to make sure I put those in the correct order in the brackets so that we get a result of 11x in the centre of the quadratic equation. Now this is the right way round for that, because if I multiply the 5 and the 2x together, I get 10x. And if I multiply the 1 and the x together on the inside, I get 1x. And if I add those together, I get the 11x that I need. There are lots of different ways of factorising quadratics that you may have been taught at school. So please, if this is not the method you're used to, then carry on using your method as long as it works. You may need to try a few different combinations using this trial and error method, but if we know that it does factorise, this method will work. Okay, so here's your first chance to practice those skills that we've looked at. So on page 13 of your textbook, you'll see exercise 1.1. Have a go at those questions, mark them yourself using the back of the book, and if there's any problems that arise, get in touch with your class teacher and they'll be able to help out with any problems you might have. Okay, good. So as well as factorising a quadratic, another useful technique that we can use is called completing the square. And this is going to tell us something a little bit different about the quadratic graph, but we'll come to that a bit later on. So the general form of completing the square is shown here, but I think the best thing we can do is to actually look at an example. So the example that we're going to use is y equals x squared plus 8x plus 9. And this is a relatively straightforward one because we have a single x squared at the beginning of the quadratic. So all of these notes here can be written down in your notebook. So the first thing we do in order to complete the square is we would halve the number of x's in the middle of our quadratic. And if we halve those, we will of course get 4. So I'm going to replace my value inside the completed square general form with x plus 4. Now the reason why I'm doing that is because if you imagine now multiplying out these two brackets here, we will have x squared plus 4x plus another 4x plus 16. So we're going to get the x squared, we're going to get the 8x coming out from the two lots of 4x, and then we'll have a 16 as well. Now we don't want that 16 as such, we want plus 9. So what I'm going to do is take away the 16 that comes out of that bracket that I don't want, and then I'm going to add the 9 on that I do want, and that results in a value of minus 7 outside of the bracket. Now you'll be able to see that more clearly if you then go and multiply all of this completed square form out. You will then start to realise how that links in with the x squared plus 8x plus 9. So I'd spend a couple of minutes multiplying this out if you're not very confident with completing the square, I would multiply out this completed square version that we've ended up with, and just make sure in your own mind that we do indeed have a different version for x squared plus 8x plus 9, just written in a different way. Okay, good. So now that we've completed the square on a single x squared quadratic, the next thing to do is to complete the square on quadratics that have multiple x squareds. So this example I'm going to show you here is y equals 2x squared minus 10x plus 7. And by all means, write all of this down in your notebooks. Now it's important to know at this stage that you can only complete the square on quadratics that have a single x squared. So the first thing I'm going to do with this is I'm going to take 2 out as a common factor, and that leaves us with this. So the next step is to then complete the square on the bracket. So x squared minus 5x plus 7 over 2, we need to complete the square on that quadratic. So I'm going to set it up with a general form. You'll notice that there's an extra 2 here that I didn't need in the first example. And my job now is to find the values of q and r. Now finding q is relatively straightforward because I'm going to do exactly the same as I did in the first example, and that is to half the number of x's. So q is going to become 5 over 2 because half of minus 5 is minus 5 over 2. And then I have to find r, and the way that I'm going to find r is I'm going to multiply out everything I've done so far. Now that can take a little bit of time, but if I do that, I end up with y equals 2x squared minus 10x plus 25 over 2 plus r. And that's getting there, because if you compare that now with the original quadratic, you see that 2x squared is right, minus 10x is right, but I need plus 7. At the moment I've got 25 over 2, so what would I need r to be in order to get to 7? I need r to be minus 11 over 2. And now I have the completed square version of 2x squared minus 10x plus 7. Good. So this area of quadratics needs a bit of practice. We often find that students find completing the square quite tricky. So we've got 2 exercises here that are going to allow you to practice those skills. 1.3 focuses on quadratics that are single x squared, and 1.4 focuses on quadratics that have multiple x squareds. Get plenty of practice on this because it is quite new for some of you. And then if you've got any problems after you've marked your work, ask your teacher for help and they will be able to give you some advice. Okay, good. So we've learned how to factorize quadratics in this presentation. We've learned how to complete the square in this presentation. And the final thing we're going to do is recap how to use the quadratic formula to solve quadratics that either can't be factorized but can be solved, or you find that factorizing is too difficult. So we're going to test this out and recap using this equation here. So 5 equals 3x squared plus 8x. If you look at the top of the page, you will see that I cannot use the quadratic formula unless it's in that format. So the first thing I'm going to have to do is rearrange to give this equation. And from that, I can write down that a is 3, coefficient of x squared, b is 8, coefficient of x, and the value on the end c is minus 5. And it's good practice to write those 3 values down first. I then write down the general formula. I'm then going to replace a, b and c with the values I've just found. And that leads to the square root of 124 and the denominator of 6. And then root 124 is 2 root 31, and therefore I get these 2 solutions. And if I simplify those 2 solutions by dividing all terms by 2, I end up with these 2 as my final answers. Now you can leave them like this, you can split them up into their separate fractions, so the first solution could be written as -4/3 plus root 31/3, and similarly with the other one. But one thing we can't do or shouldn't do is try and change those thirds to decimals. So these are our two solutions for this quadratic. The last thing I want to say here is that your ClassWiz calculators will factorise, they will complete the square, they will solve using the formula, but we're not going to do that at this stage. We'll leave it, practice the skills, and then learn how the calculators will help us with this type of question a bit later on. Okay, good. So this exercise practices the skill of using the quadratic formula. So have a good look at these questions, have a look at how varied they might be, and do a few questions from each of the sections. And again, mark your own. Any problems, see your teacher, and that completes this presentation on quadratic functions.